Okay, please remember whilst watching this video to make notes. You need to have a pen and paper, and you'll probably need a calculator today. Write down anything that will be important later. Listen again, make sure you use the benefit of the video, and that is that you can rewind, you can listen again if you didn't quite understand something. Be prepared to pause. I will on occasion ask you to pause to read something or complete an activity. And remember, you do need to do the activities. Real learning does come from participating, not passively listening to a video. Okay, to begin with, I'd like you to have a go at these 4 questions. They're all focused on area, and then so pause it now, have a go, and unpause it to get the answers. Okay, the answers for these are here. The first one, you should have multiplied the 10 and the 13, not use the 15 because we don't use that distance for area. The second one, pi times radius squared, the radius was 7, so 49 pi, which is 153.938, etc., which to 3 significant figures is 154. Remember, with the significant figures, you start with the first number that's not a 0. Here it is a 1. Count along, in this case 3. 1, 2, 3. Draw a line and use the next number to round. In this case, then 9 is enough to make the 3 become a 4. Here, the greatest area, well, the triangle has an area of 30. If you got 60, you forgot to half it. And on the trapezium, we had 42 centimeters squared. The trapezium wins it. Final one, depending on how you approach this, you'll have 2 different methods, either the first or the second box probably, and then this answer here. Okay, so 174 centimeters squared for the surface area. Remember, that is all 6 faces, not just the 3 you can see. So you need to work out the first 3 and then double it in some way. Okay, so today's lesson focuses on the volume of prisms. So today's date and title are there. Copy those down before you continue. Okay, today we're going to be looking at volume. Because there's a lot of different formulas for volume, I suggest that you keep a separate sheet to one side to record various formulas, diagrams, and little bits that are helpful. Okay, that way you'll have something to refer back to when we're working between pyramids, spheres, and prisms. Also, you really ought to be using a scientific calculator at this point. If you're using a basic calculator, you may find certain bits much more difficult simply because of the limit of the calculator. Okay, we can adjust for that, but it would be much easier if you could get yourself a scientific calculator. So, prisms. This is the formula we use for calculating the volume of any prism. Okay, we modify this formula depending on what we're doing. But we need to know an area of a repeating face and times it by the length. Okay. Now, the repeating face could be a triangle, a rectangle, parallelogram, trapezium, any old irregular shape. It changes from question to question. The length may in fact look like height or depth. Okay. They're all really the same thing. Okay. And you'll start to see that really clearly as you do a few of these questions. If you're struggling quite a little bit at this point to imagine what a repeating face looks like, if you think of a loaf of bread, the front face is our first slice here. So if we could find how big that face is, and then work out the length, how many slices there are, we could use those 2 facts, multiply them together, and get our volume. So here are a series of 3D shapes. Which ones of these are prisms? Well, they're all the ones that look like tunnels. There you go. This would be a tunnel that has a square. This is a tunnel with a rectangle at the front. A cylinder is a tunnel that's circular. Think of a pipe, for example. Okay, a triangular prism, better known by many as the box of Toblerone, comes in. Okay, prisms have one shape at the front or at the top that repeats the whole way through. Okay, so that circle at the front is the exact same size circle that runs a whole way through this cylinder. If you compare that to a sphere, where obviously it's just a ball, or these pyramids, where you have a base shape which then comes up to a point, so that changes as you go through. This is also a cylinder, okay? And, sorry, this would be our length. And you can see probably why, that actually we say length, but we could sometimes mean height or depth. So, at this point, a quick reminder, you need certain formulas. You should know all of these, but if you don't have them firmly lodged in your brain, I suggest you copy them down now in whichever form you prefer. A parallelogram, to get the area of a parallelogram, base times height, perpendicular height. So the height must meet the base at a right angle. If it doesn't meet at a right angle, it's useless. For a triangle, it's either half times base times height. Again, these meet at a right angle. Or base times height divided by 2. I would say that second one is easier on a simple calculator, but either of those would do the job. And a trapezium. Now I prefer this form for the trapezium. I don't mind if you instead use that one, as long as you're using a correct formula for a trapezium should you need it. If you need any of those, copy them down now before you continue. So, prisms. Volume of a prism is always the repeating face times the length. Here we have a repeating face, a rectangle. Now we have a cuboid. Okay, the rectangle at the front is that repeating face. This 10 is our length. So the volume of a cuboid is this front face, which in this case would be 35, times this 10 here. So 5 times 7 would be 35 to get the repeating face, times that by the length, 350 centimeters cubed. Notice the cubed for volume, squared for area. A triangular prism, we find the area of this front face, this repeating triangle. Well, 6 times 10 divided by 2 is 30 for the front. And then we're going to times it by this length here, 30 times 4, 120 centimeters cubed. Again, make sure you're copying down any diagrams that you need for your reference. If you're working on a computer as well, I don't mind if you use that to represent the cubed. I know it's difficult to get the little 3 properly on a computer. So here is a parallelogram. We have a front face that is there. So this is a parallelogram prism. The repeating face, 9 times 5 to get us 45. And the volume is always the repeating face times the length. So we're going to take that, times it by 10, 450 centimeters cubed. And finally, a trapezium prism. Okay, so again, we're going to focus first on that front face. That repeating face is going to be the same the whole way through. A half times 4 plus 7, because we've got to add the parallel sides together, which are those two, times 5. So a half times, this is 11 times 5. Half times 11 times 5, 27.5 centimeters squared. Times that by the length to get 110 centimeters cubed. So, here are 9 questions ranging from cuboids at the top. We've then got some triangular prisms. We've got a couple here and here that are trapezium prisms, and one. At the moment, I'm not going to give it a name. You can decide what you would call that. But I'd like you to get the volume for each shape using what you've just seen. Pause it now, have a go, and then unpause it for the answers. Okay, here we have our answers. If you got 480 for question 4, 240 for question 5, or 528 for question 6, and you forgot that you need to half for the area of a triangle. Okay, so that's why you've got a bigger number than I do. This one in 8, you could treat that as 2 separate triangular prisms, each 3.5 tall. And then you will get the volume of 94.5 meters cubed. The final one does have a massive answer, but it is correct. Okay, the trick here was to realize that that was 104 as well, then you've got a trapezium with a depth of 65. Right, we can also use the exact same method to find the missing length on a shape where we know the volume. So here we have a volume of 960, and we have sides that are 20, 8, and y, and we want to know what is y. So, to do that, we're going to use the same formula, but we're going to say that the volume equals, this here would be our repeating face, times our length. Okay? Well, we know that we can clean this up a little bit. 8 times 20 is 160. So what we're saying here is the volume of 960 is the same as 160 times whatever y was. Well, if you divide both sides by 160, you've got a calculator to do that, you'll find that y is 6. So to get that final one, we're going to divide by 160 on both sides to work out a single value of y. Y is 6 centimeters for that one. I'd like you now to pause it here and have a go at the second question on screen, which is here. It's very similar. Okay, the answer for this one, we should have first written that the total volume here is 990, and it's going to be the same as y times 9 for the front face times 11, which is our length here. We can clean that bit up again to get 99, so 990 is the same as 99y. Divide both sides by 99, and you'll get that y is 10 centimeters. Okay, so there's that example from previous, just in case you didn't have time to copy it. Here are 3 questions using that exact same skill, and I want you to think very carefully on the yellow one. What is special about a cube? Okay, pause it, give these a go, and then unpause it for the solution. Okay, here is the answer to the first one. You should have got from the text that 2,700 is the volume, which is equal to y times 9 times 10. So 2,700 is 90y. Divide both sides by 90 to get y equals 30 centimeters. Second one, a cube means that all these 3 lengths are going to be x. So the volume is x times x times x, or x cubed. The volume is 27, so 27 is the same as x cubed, so a number cubed is 27, and if you cube root 27, you will find 3, okay? Because 3 times 3 times 3 would give you 27. The green one, firstly, the volume of the one on the left is 56, 7 times 4 times 2. On the right, the volume is going to be y times 1 times 2, or just 2y, because 2 times 1 is 2, so 2y. Since they have the same volume, the 56 on the left is equal to the 2y on the right. Divide both by 2, and you'll get y is 28. Right, next we're going to move on to cylinders. And okay, the cylinder is a special type of prism. It has a circular cross section, a circular repeating face. Think of a beans can or a Pringles tube. Okay, you will need first find the area of that circle to find the volume of a cylinder. So the volume of a cylinder is found by first finding this repeating face, the circle, and then multiplying by the height. Okay, so area of the repeating face times length. Well, we call it length, but really we use h for height. Pi r squared is the repeating face, and the length is just our h. So in this, so we do pi times the radius squared times the height. So an example such as this one, the area of this circle first of all would be pi r squared. Pi times 3 squared, and 3 squared is 9, so 9 times pi, or 9 pi. The answer is going to be in terms of pi, so there's no point in putting that into your calculator, leave it as it is. Then we're going to take that answer, we're going to times it by our height. 9 pi times 7 Well, 7 9s are 63, 63 pi centimeters cubed. You don't need to write it as a decimal. Okay? It says specifically in terms of pi, which means this is a non-calculator type question. If it wanted a decimal place or it wanted significant figures, that's where you'd use your calculator. I have included at the top of that example there, and I'd like you to have a go at finding the volume of each of the cylinders below. Firstly, I'd like them in terms of pi, just as we did in the previous example, and second, to 3 significant figures. Now, we covered this in the starter, but just in case you don't remember, what you need to do is put that into your calculator, and 63 pi would be a 197.9, which, if we round to 3 significant figures by drawing my line there, would be a 198. We take our first significant number, which in this case was a 1, take the next 3, and then round from the one after. So have a go now. I'm going to put the answer to the first one up so you've got something to go by. You should have got 300 pi for the first one, or 942 to 3 significant figures. I want you to have a go at the others once you're confident enough, and then check your answers. Okay, the answer to these questions are all coming up on the screen now. The most common mistake here is people forget to square the radius. They just use pi times radius, so just be careful of that. The second set of examples I'd like you to also have a go at. I just want you to bear in mind that on these ones you're given a diameter, so you need to compensate and realize, well, that is actually a radius of 4, so my circle for the first one would be pi times 4 squared, not 8 squared. Have a go at these and then unpause it for the answers. Answers are now appearing on screen. Check as you go and make sure you've not made any mistakes. If your number is far too big, it's because you used the diameter instead of the radius. That's the most common mistake we're going to see on questions like this. Okay, we can also use a known volume to work out a missing distance, such as the height or the radius. This one wants to know the height, so what we're going to do first is find the area of the circle. Well, the radius is 8, so our circle is 64 pi. I'm going to leave it in terms of pi for now to make sure my answer is as accurate as possible. Then I can work out the height by using the volume we know and dividing by that area of a circle. So the volume is 1400, divide by my 64 pi I got a minute ago, and you should get an answer of 7.0 when rounding to 1 decimal place. The other type of question you might get is where you have to find the radius. So here's one. It wants to know what is the radius if the volume is 700 and we have a height of 9 inches. The area of the circle, first of all, we can find by doing the volume and dividing by the height. So this is another manipulation of our formula from before. The volume is 700 and the height is 9, which gives us 77.7 recurring. Don't miss that little dot there. It's not very clear on some calculators. Next, we need to do a little bit of very careful stuff, because we know that the area of a circle is given with pi r squared, and we know that the area of this circle is 77.7 recurring. Divide that answer by pi to give us what the radius squared is, 24.7574. And then, to find out what just one radius is, we're going to square root it. This is where a scientific calculator is very handy. So r in this case is just under 5 inches, 4.98, 2 decimal places. Okay, here are 3 questions where you need to find the height. Be very careful. I've been very kind and pointed out that this is a diameter, not a radius, and I've left that example up top for you to help guide you. Pause it, have a go, and unpause it when you are ready. Okay, if you got these right, you will have got 14.1 centimeters, 8 feet, and 10.6 inches. Be really, really careful on these. You should have been able to get those if you did exactly what we did. Find the area of the circle first, then do the volume divided by that area. Round it appropriately. Here's the second type where we had to find the radius, a little bit trickier because there's a square root involved. So the examples on the board again. 3 questions. I've only made it so it's all radiuses, it's all volumes, it's all kind of the same to make that as kind as possible. Give it a go and then unpause it. Okay, so the answers for these: 3.1, 6.9, 6.3. Okay, that's the last of the questions. So once you've finished, make sure to submit your work to your teacher. Well done for today.